Okay, so let's get started then. So the session we have now that I'm planning to do with you is I want to talk a little bit about Python specifically and compare with other languages that are used with NSO, and then go through a Yang model and some Python code for a service. If that's what you want to do with me, then stay here. We have plenty of time for this, so if you don't help me with any questions, you'll get a lot of coffee later. So please make this interactive. And I was thinking, I mean, you sometimes go to YouTube or something like that and see a programming tutorial, and some cool guy there sits and just types in all the commands and everything just works, right? I decided not to do that. So I have a ready-made solution. It's all working. You know, standing at the podium and programming isn't working well for me. So I have a ready-made solution, and we will go through it line by line and show what it does and why it's doing whatever it's doing, and stuff like that. Let's have a discussion. It's much more fun than me just reading up what every line is doing to discuss why is this and why is that. So you are a great part of this presentation this time, okay? You helped me a little bit. Some of you were here before the break and helped me a little bit with the previous presentation too, but this is going to be a lot more interactive, I hope. Okay, so Python. How many of you are Python programmers, Python aware? Something like half or so, okay? And for the rest of you, what are you expecting to get out of this? No, I mean, seriously, you can get a lot of stuff out of this anyway, so you shouldn't be too worried. If you are somewhat used to programming, this should be fine. We are doing a lot of Yang, and then you can understand how a service works in general, even if you don't care about the Python specifics. Okay, so let's first compare the Python bindings in NSO. Python is the most recent addition of languages that we have integrated with NSO. So it's only been here for around a year. So a lot of people have implemented stuff already, but in Java, because that was what we had from the beginning. And Java is great for people that are sort of have a computer science background maybe, but less so for network engineering background. And we are talking about DevOps all the time, so in there, Python plays an important role. It is, for somebody who hasn't been trained on Java already, Python is always easier. It's a lot easier than Java. I recommend Python to everyone that would like to learn how to use NSO. Okay, so if we compare these different languages, we have Java, Python, and Erlang as the three officially supported languages for NSO. And if you see, there are some different APIs here. We have the service API, the net API, subscriber, opper, data provider, action provider, notifications, schema, and high availability framework APIs. And to see how they are represented in these languages. If you're not terribly familiar with NSO, much of this may not make much sense to you. But if you look at the service APIs, in Java, you have a choice. You can either use the raw MAPI, which is the low-level APIs, or you can use a nice little abstraction layer on top of that, which is called Navu. So that's your choice. When you're making services, you will have to pick one or the other. With Python, it's a similar situation. You can either use raw MAPI, or you can use magic. The double A in magic there is alluding a little bit to, it's sort of like MAPI, but much nicer, in a very Pythonic sense. Things become very natural in magic. Actually, I think that magic is the best, nicest API in all of NSO. It's really nice. I'll show you. And in Erlang, you have raw MAPI, and that's it. If you want to write NEDs, you still have to do that in Java. Maybe somebody can make some experiments with Python or Erlang for NEDs too, but really the only officially supported NED API is in Java. So for all the NEDs, they keep Java there. But there's no problem to write your applications in Python and consume other packages that are written in Java, obviously. We have the subscriber APIs, CDB APIs, the same in all. You can write operational data. You can write data providers. It's all the same in all the languages, really. Of course, the exact syntax varies a little bit between the languages, but all the same functionality is available, and the functions are pretty much called the same things. For notifications, Java has a different notification API. For reading about the schema, seeing what's available in a Yang model without hard coding it into your code, Python has this magic API, which is great, making that a lot nicer. If you look at a few details around the implementation of these languages, where do I find the implementation? For the Java code, it's under Java jar, and Python is under source NCS Py API. You may want to go there occasionally to check out those source files, to see how different functions actually work, what arguments to take exactly, and what not. So sometimes, at least, when I program, I go there to look at those source files, and that makes sense. And for Erlang, it's under source NCS econfd. Since these names are have different patterns, it can be good to have in one place to look it up. The documentation is easier to find if you understand that econfd means Erlang. Log files, in the Java case, all the log output from a Java program lands in the same Java log file, ncs-java-vm.log. In the Python case, the startup and close down of Python packages goes into one file, that's the ncs-python-vm.log. But the individual log messages within that package is then going to separate log files, one for each package, called ncs-python-vm- and the name of your package.log, which is, I find, very convenient, because otherwise, in the Java case, the log file grows very large if you have a half dozen packages. In Erlang, you have to do your own logging, so you can call it whatever you want, structure it however you like. Another difference when it comes to running in the VMs, when NCS or NSO starts, it fires up one Java VM, and all the Java applications are running in this one VM. You can, of course, override that and run your own VM and whatever you want, but normally everything runs in a single VM. With Python, there is one Python VM per package, so they all run in separate VMs. Python is more lightweight, and so I think that makes good sense. And in Erlang, you can run in two ways. Either you fire up your own Erlang VM and run your code in there, or multiple applications if you like. But the cool thing about Erlang, you can run inside NSO itself. NSO has an Erlang VM built in, and you can run your code in that VM. It's sort of, you get a lot of power, but also responsibility, right, if you do that. But one of the things that is making that really cool is the performance that you can get. Since you're running inside the process, there's no context switches from one process to another for every message or every API call that you're making. So it can be really fast. And so one application where that speed really matters is in transforms. I will not talk today about what transforms are, but if you are aware of that or want to know, you can come to me later. They are really making a lot of calls. So for transforms, it makes good sense to write them in Erlang. But services are great in Python. They map very nicely to the Yang models, so it makes it very easy and very close to operator worldview when you write it in Python. And of course, since NEDs can only be written in Java, officially at least, I recommend Java for that. As I just said just before the break, you can of course mix. You can write one package in one language and use another language for another package. That is the key thing. You have Yang as the interface. So don't be afraid just because you have 3 other packages in Java that you inherited from the previous project. That doesn't mean that you cannot write one in Python, because Python might be easier for you. Any comments or questions on the runtime environment of Python and Java or Erlang? Oh, I'll not force you on this one, but later you will have to make it more interactive. Okay. As you may know, in NSO, you create packages using the NCS make package command. Actually, it's just a glorified script that is doing make-dir a few times and copying a few skeleton files. It's nothing really, you can do that manually too, but it's kind of boring to write make-dir 5 times. So you have this NCS make package script, and then you can say what kind of package you want. Either you want an Erlang package, there's only one Erlang skeleton for all kinds of packages, but if you're using Java or Python, you can specify which type you want. You want a service skeleton or a data provider skeleton and so on. And if you select to do a service, you can choose to do one with a template or without, or only template, or Java template or Python template. Now, if you're from the back rows, you can move forward if you want to read this. If you look at how this looks in Python, we have a number of different base classes for different Python type of applications. So you have a service or nano-service or action, and so you inherit from these base classes and implement something with the same call signature to implement a service of this kind. And then you have your own my app, which is a type of application, and it registers these subclasses that you have, foo service or foo nano service and so on, saying I'm responsible for this. That is the mapping between, this is how you registered your classes, so it knows what to call. As seasoned Python programmers, you know about this __init__py file. If you are making a Python application that's not having all Python source files in the same directory, you can have subdirectories with more Python files and so on. But then you need to have an __init__py file in each subdirectory to explain to the Python interpreter, yes, we are still part of the Python here. Don't forget that. It can be empty, if you like, but it still tells the Python interpreter. Just the mere existence of this file tells the Python interpreter, yeah, you can look for Python files in here. The file itself does not need to contain anything. But if it does contain something, the Python interpreter will execute those lines. So in there, you can, for example, import particular other Python files, if you like, or say that __all__ equals, and then 3 subdirectories, and then we'll go to those 3 subdirectories and nowhere else to look for more Python files. So that is the general Python-specific structure of Python applications. Really has very little to do with NSO, but you should be aware of this when you look at our examples. I talked a lot about magic, saying this is the great thing. So let's take a look at what magic looks like. I mean, I told you before the break that NSO is totally model-driven. You start with the Yang model, and everything is derived from the Yang model. So we need to be able to read and or write those things that are described in the Yang model, see the input values and write things to the network. So it is, of course, crucially important that we have a nice integration with Yang models in our Python, and that is what magic does. So you just use notations with using a dot to navigate the structure that you have in the Yang file. So in your service code, you will get an object called service, which is pointing to your service in the Yang tree, and another object called root, which points at the root of the Yang tree. And then you navigate in the Yang structure by just saying root dot, for example, my namespace ___ top. So then there's a leaf top. No, sorry, it was a container top in the my namespace. And in that container, there was a leaf called val. So that's just how you see v equals root.myns ___ top.val to get that value. No function calls. You just refer to this object, and you get the value right out of the database as navigating by the Yang. And if you want to assign a value to val, well, let's just reverse root.myns __ top.val equals v. That is how you change the contents of your transaction. That make sense? Come on, some feedback, please. Yes. Thank you. Exactly. If you compare with, for example, Navo, which is the Java's nicest way of doing this, you would have like NCS root dot container myns comma top dot leaf val dot value as string. It's a little bit more verbose. Or if you want to assign some value to it, then you say NCS root container minus top leaf val dot shared set. It's a little bit clumsier. The integration with magic makes your code really flow. It really becomes one with the Yang model, and that's really crucial for writing services. I love that a lot. You can also use the map if straight. But in all three languages, actually, in Erlang, in Java, or in Python, you can use this MAPI method. So there are function calls like getLM, shared setlm, and so on, which takes some arguments and then a path and a value. So you can do that too if you want. In some cases, actually, that is beneficial. For example, when you have an application that doesn't really know about the Yang model, but just translating from one to the other. So sometimes you want to abstract paths away. So you can do that too. Yes?
This is an object. When you use magic, then you create an object that is actually the Yang model, right?
Yeah, you get to your application, you get the root object and the service object, and by using the dot operator on them, it is creating more and more objects navigating in the Yang structure that represent those things in the Yang. Yes?
When does the object get created? When you traverse the tree, or initially with the full, all branches and everything?
No, it's basically these objects will be created when the Python interpreter comes to this line, so to say. It actually, that is important. I mean, maybe you would want to have this as an upfront cost and it's done once and for all, but it's really good that it isn't. Because if you take a Juniper router and an iOS XR router or something like that, the models are huge. So it would spend many seconds just creating objects and doing nothing else, maybe 30 seconds for the XR and 30 more for the Junos before your code actually runs, which touches two leaves, right? So it wouldn't work. Those huge device models, you don't want to take the cost of creating something that represents all of what they have to say in memory before you touch something. So this is a sort of lazy thing. It's happening as you traverse that line. Yes?
There's a MAPI function called xpath-select.
Yes.
Similar Python magic.
Not as that, but you can use the MAPI select function in Python as well if you want to do that. If you want to find all the nodes that match certain criteria or something like that, you can do that using the MAPI approach. But if magic is only navigating concrete objects in the Yang model.
Okay, so you cannot do the
XPath selection, select me all the nodes, all the interfaces that have an IP address like this or whatever it is. I mean, you can do that using the MAPI approach, but not using magic. So we'll take a look at some service code that is using magic in a bit. I just want to go through a few more slides, and then we'll actually open up the text editor, programming editor, and have a look. When you are working with Python, it may sometimes be convenient to just, I mean, you are in your transaction inside NSO CLI or something like that, and you say, what is the Python representation for this object or something? Or what if I do an XPath select function on something right here? So it's easy to make a command in NSO, and in fact, we have one in a package called IPython superuser, so that if you install this package in your NSO instance, you get an NSO command called IPython. If you type IPython, either in operational mode or inside the transaction, you jump over into a Python shell with access to the currently running transaction, where you can do manipulations or searches or whatever in Python in your running NSO system. There's a lot of power in that. If you are anything like Python programmers, you should feel something bubbling up inside you now. It is a lot of power that comes with this. But of course, as we always say, with power comes responsibility. You can really do bad things if you do this. And one of the things you can do as you drop over into Python is that you suddenly get access to all data, encrypted or not, and everything else. All access control rules are now gone. That's why it's called IPython superuser. You have full access to everything. Okay? So don't install this on the production server. That would be what they call a security hole. But for development, I find this very convenient, because then you are inside the transaction, made a few edits, and now you want to make the code that's going to read those things, and then you can just type in the Python interactive shell and see what it looks like. And IPython is pretty nice. It has nice tab completion and stuff like that. It's really nice. And the IPython superuser lives on the NSO package library. So if you have access to that, you can get it from there. Huh?
It's also on GitHub.
NSO package library is a GitHub section. So. Exceptions. So when you're programming, you will often find the need to throw an exception or something like this. And it's really, in Java, it's quite a few lines of typing before you get, okay, I want to have the pool is exhausted or pool not found or whatever it is, kind of exception. You have to type for a while. Here it is really simple. You say class pool not found is the type of exception and nothing in it. And then you can just say raise on this one and give an error message. So it's really convenient and easy to throw error messages to the user. This message will now come in the phrase of the operator when he's trying to commit something, something is wrong with his config, and he will say no. Make sense? Now we have this lab, lab number 1. We want to write a Python service. I will make this lab available as a lab package. I've been giving a lot of lab trainings in my days, and the way I usually do it is I prepare a package with some content given, so you don't start from zero. You have maybe a YANG file or part of a YANG file or something like this, or maybe part of a Python or something like this, and you're supposed to implement whatever is missing. I'll put this package for this lab up on the hub, so you can go and download this. And then after everybody's done the lab, I mean, when I do the trainings, I usually go through one solution, my solution of this, and explain everything. And what I will do today is only this latter stage, because you will not be picking up your laptops and doing this lab now. I will just explain the solution. But if you are interested in this and getting better at this, after having seen me demonstrate the solution to you and explain it, you can go home and try to do it on your own one more time. That is a very efficient way of learning how to do this. Okay, so I want this application. This is a real-world example, actually. Somebody asked me, how could I make something that is doing the cross-classification? We're doing that manually right now. It's a lot of work. We are defining some, I'm not a networker, right? So we have some different cross classes for our traffic. Some is highest priority, some is in the middle, and something is on the bottom for all the bits that's left over. And now we have lots of different applications that are running. Maybe some VoIP application needs to have a high classification. Facebook should be low. The backup can go on the low. So you have a lot of applications that need to be classified into which of these different cross classes. And that is the cross classification. And adding and removing these applications now is quite tedious because, okay, it's not so much information that you need to write for each one. You could actually go and write those ACL rules manually. But the problem is you want these rules to go out to all the devices in your campus network, maybe 200 of them. So you have to do the same thing 200 times over. So then it's kind of nice to have a service where you say, for all the machines in this device group, can you please push out and make sure that they have these cross rules for classification? So that's the service that I want to make with you today. So every flow is based on which protocol it is running, TCP or UDP, from which port or port range it is coming, source, and going, destination. Sometimes you may want to also match against a particular DSCP value, so it only matches if DCP is 17 or something like that. And then for each of these flows defined by these match criteria, assign one queue. Yes, this goes on the scavenger queue, or this goes on the video queue, or this goes on the high priority queue, or something. So that's this very small and simple application that we want to write. Does it make sense? You want to stay? Okay, great. So this is what we'll do now. But I also have a lab number 2, which is about a little bit more complicated service called reactive fast map. Maybe I shouldn't show that right now, but okay, here it is. I have a lab 2, which is defining a totally different use case. We can do that. And I will do that after the break, after the coffee break. But this is the one to do now. Before we jump into code editor. Any comments or questions? Can you read that? I can try to make it a little bit larger. That's better. Okay, the first thing I want to do is write a Yang model, right? A Yang model, let's call it classifier because it's only doing the classification part of this. It's not doing anything else. So you know how you write module classifier, you give it a namespace. You have this namespace string here. The only value with this really is to be world unique. Nobody else should come up with this same string. So now you Cisco folks, you should remember that classifier is used up. I have it. And then since these test namespace strings tend to be pretty long, we should have a short, nice prefix so that when you are importing this file in some other Yang file, you can use classifier : to refer to the objects in here. Okay, I'm going to use some INET, ITF standard INET types like IP address, and some tail of common stuff like service. Description, I didn't fill that in. Okay, then we have a top-level container called CrossClassifier. So everything that has to do with my service will go in this top-level container, CrossClassifier. It goes on all the way to the end here. Then I have a list queue name. Remember, I had to have this scavenger, high priority, whatever they are called. They have something like maybe 4 different queues that you can use in a typical router. So we have to give them names. And I chose to put that in its own part of the configuration. So I have one part of the configuration for this service is a table with the names of those things. Just the name, nothing else. Because then, since I have this in the Yang module, I can refer to them later with leaf refs. So things are nice and tight. There will be no spelling mistakes because I just used a string. But now when I use a leaf ref lowdown to point to the queues, I'll just point to one of the queues that are configured here. But this is technically outside the service. It's something that it's a control table, if you like. Something that the product manager will decide. Here are the 4 queues that we have, and no particular service instance can change that. Then we have the actual services, service instances. Each instance is called an enterprise network policy. A typical use of this policy might be that you have only one network. It could be that, normally you would have the same across your network. But maybe you have a campus network and a lab network, and they should have different policies or something like that. So I just decided, let's make this a list of instances, even though the most common number of instances might be 1. Each instance should have a name, which is just any sort of string. You can call it whatever you want. You can even use Japanese characters if you like. Strings are supporting them. Then we have uses NCS plan data and service data, and NCS, it's most importantly here, NCS service point CrossClassifier. We will later see that the Python code needs to say, I am responsible for CrossClassifier service. It needs to match. The Python code will say, I am CrossClassifier. This Yang code here says, I am CrossClassifier, and that's how they match. Make sense? How many have seen anything new yet so far with this presentation? So some of you have not seen this in some sort of training or something. Okay, good. Okay, yes? Yeah, okay, so we can start with service data. As you remember, if you were here before the lunch break, NSO keeps meta-level information about each service instance. For example, the undo information I was talking about in FastMap. And this information needs to be somewhere on each service instance. And that is inside this service data. There's some other meta-level information, NSO information about what the service contains and is doing. And the plan data is a sort of newer feature. Some services can expose their reactive FastMap behavior or their state convergence behavior, saying that I am now, so far, I have progressed through the first 5 stages of my creation, but not up to 10. So then it can explain that I'm halfway through, or I'm waiting for this to happen now, and so on. These stages, when exposed as state information for the service, they're called plan. So a service can explain, I have these 10 things I need to do before I reach my goal, and that's in my plan, and I'm right now on stage 5, and here's some parameters, what I'm waiting for, and so on. So if you want this particular service that we are implementing here today, will not make use of any plan data. But if we wanted to, we could have used that plan. I can delete that line for now, if we wanted to. But this makes it future-proof, so that whenever we upgrade this service to something that's using plan data, it's already here. I think actually it's in the template for when you make a service packages these days. That's why it's there. Any other comments? Okay, so inside the service, what do we need to configure for every service instance for this CrossClassifier? Well, we have the name, but now we have to decide which devices should I do this to. I could, of course, have had a list here with all a list of device names, and somebody could just configure the west router, the east router, and the north router, and so on. But instead, we decided here to model this as pointing to a device group. So you can define a particular device group, and then this will be applied to that device group. And you can, when you have the device group concept in NSO, you can already make devices part of the device group, and also other groups as part of a device group. So you have a full flexible system for that already. So just pointing to a device group makes sense here. And we say that this is mandatory. You have to fill. The service cannot do its work. There's no way you can do anything really seriously if you don't specify which group this should apply to. Then we come to the meat of this service. Remember, we're about to classify applications to which queue they should be assigned, right? So, of course, we have to have a list of applications. Each application is given a name, which is just a string. It could be Spotify or Box or the backup plans, whatever it's called. For every application, we have a container with filters. Every filter has 0 or more flows. Every flow is keyed off by a protocol, which can be TCP or UDP, a source port, which is just a port number, or the word any. We might not care about the source port or the destination port, or both of those. Say that anything with TCP/17 goes this way. So we key these rules off by source port and the destination port, but they can be any potentially. The definition of this port number or any T was up here. I just scrolled past it. So port number or any type is a union of a numeration with a single value, the word any, or an ITF INET port number. That make sense? Yes?
One question before we go too far. You have the list enterprise network policy, you have the key name only.
Yes.
Would it make sense to have key list the device group as well? Otherwise you would potentially overwrite.
Yeah, the way, okay, you could definitely do something like that. You could use the device group name as a key to this to make sure that you cannot have 2 enterprise network policies for the same device group. But since the device group may still contain overlapping devices, it doesn't provide all that much protection anyway. But yeah, it's a fair point. Right now, I mean, this service, if you're pushing this service onto a set of devices, and some of the devices are overlapping with another enterprise network policy, there may be strange effects for the ones that are overlapping. Are we classifying like this or like that? So if you have the campus network here and the lab network there, they should probably be disjunct. All devices here have some set of rules and these other have some other. But if you list some devices in both, well, you'll get some interesting effects. Any other comments? Remember, this is interactive, right? Okay, then we have some nice Yang tricks here. Okay, remember the source port was just a port number, but sometimes we want to match on a port range. So from a certain port until a certain other port, all the ports in between. So then I say, okay, it says source high port, which you only set if you want to have a range. If you don't set it, it will be the source port only, like 4711. And if you set this one to 4900, it will be 4711 until 4900. But this is only applicable when the source port is not any. So then you say this when statement on this one. Say this one is only relevant, can only really have a meaning when the source port is not any, because there's any until 4900 doesn't make sense. And also, must current greater than source port. We only want to have the source port to be lower and the high port to be higher. So then we have this constraint. It can be any number as long as it's also greater than the source port. Make sense? Come on. Yes. Thank you. And the same thing for the destination high port then. DSCP. It's an optional thing. Yeah, I didn't put mandatory on it. So if it is there, you want to be able to set it to a value from 0 to 63. We have a description which explains what this flow is about. And since we are talking about port numbers and DHCP numbers, it's kind of hard to remember exactly what all those things are. So it's good to have a description. That's why it's mandatory. You have to actually fill something in. If you forget that, your transaction will fail. And then also, finally, a pointer to which queue. Okay, now we have all the parameters for the match. We even have a description for this thing. But what queue do we map it to? Is it the high priority, the medium, or the scavenger? Mandatory. You have to fill it in. With NSO 4.4, these sort of mandatory things here are actually checked before your service code runs. So do put them in. Yeah, celebration, please. Because earlier on, in previous releases, these things were validated by NSO, but they were validated after your code ran. So you still had to check for everything being in range and being present and stuff like that. But now things moved around so that we have wanted this for years, but now we have it. So things are actually validated before they are passed on to your code. Okay, that was the service Yang model. What was that? Couple of pages. Even in these large fonts, it's just a couple of pages. That is often how service models are. They are pretty short. They should be short because they are capturing this high-level concept of your service. You don't want to give your customer 200 parameters to fill in. It will feel like doing your taxes, like form after form, or getting insurance or something, like form after form with questions to answer. You want things to be simple and high level, at least in the normal cases. So service models are usually quite short. Okay? Who thought this was interesting to go through this Yang model? Good, everybody, that's great. Let's have a look at the Python then that goes with this. What does a Python create code do for this? I mean, first I should say, this is a Python plus templates service. So it is using XML templates to actually push things to the devices. And I recommend that. Do that. You don't want to have Python code that's doing everything on its own, usually, most of the time. You want to have a Python code that's doing some of the computations, and then templates that are doing the mundane copying of values from here to there and so on. So I do definitely recommend it. And I will show you the templates too, because they are important as part of this. But let's start at the Python code. Just to give you a feeling, it's about, what is it, page and a half. And half of that is comments anyway. Okay, I remember I showed you have to create this class of your own service and say that it's an application. This class is only really doing two things. It's doing setup and teardown. And the setup consists of, in this case, just two things. One saying, hey, I'm alive. Self-log info, I'm running. And the second thing saying, okay, I am the CrossClassifier. This is what tells NSO to map, okay, when I create one of these instances in the Yang for this service, who do I call? This is where you're going to call. call the service callbacks, which is the thing up here, service callbacks. Go there to find out what to do at this point. And tear down, if you want to do something special when this package is terminating for some reason, somebody may be unloading you or upgrading to a new version or something, well, this one only says, okay, I finished, that's all. So it's really the plugin work, the work that you need to write, the boilerplate kind of things that you need to write to be part of this is really just a couple of lines. And then the interesting things happens in the service callbacks, and the only one that I care about today is the callback create. You have this little annotation at NCS application service create, which is just decorating this function with this little label, so that the NSO Python environment can see, oh, that is the create function. It's not going to look at the name of your function, a cb_create, and just call that one. You can call it whatever you want, as long as you have this decoration on it saying, I am the create function. Okay, so what does the create function do then? You can take a look at the signature at the top. You have the self, the tctx, the root, the service, and the prop list arguments to your service function. So what are those? Well, self is the object itself. In Python, the first argument to a class, in a function call to a class, a member call, that is the pointer to the class itself. tctx stands for transaction context. And if this create function, for some reason, would like to know what is the username of the operator that's logging in right now, or what is his IP address, or is he coming in through the web UI or through netconf or whatever. A lot of boring stuff like that. That is all available through the transaction context. If you navigate deep down into those structures, you can find out. But most of the time, you don't really care about tctx. Sometimes, if you are writing some code and want to start your own transaction and stuff like that, you can refer to this tctx. But yes?
So you can block someone named Peter?
Yeah, if you really wanted to write a service that will not work for Peter, you can do that. Or that behaves differently over netconf or whatever. I mean, you can all sorts of dirty tricks like that if you really wanted to. Okay, another log message saying, hey, I'm alive. And this is now logging on the debug level. So it's only if you turn on Python logging to the deepest level that you will see this message. Otherwise, the log will not be filled with crap. But if you turn it on and really want to see, yeah, you will see service equals and the name of that service instance. We create a template, just in this case, an empty template for this service. So TMPL will then be, you will see, you will apply templates using this template object here. Now I want to, whatever I do, when I push things to the network, I want to push to all the devices in my device group, right? So I would like to repeat this process for every device in the device group. So how do I find out which devices are in the device group? Well, we got the root object here. This is pointing to the root of the Yang tree. So I then go root, devices, device group, and this matches exactly what you see in the CLI, right? It's actually one difference here. You see in the CLI it's called device-group. Since that would turn into minus in Python, all strange symbols like that are turned into underscore. So device_group. And which group? Well, then you need to look in the service. Go into the service Yang, look up the device group leaf. Put that name in here to find out which group we are talking about, and then get device name, which according to the NSO built-in Yang models is a list of device names. I'll show you the Yang just to remind you. Okay, this device group here matches exactly this leaf here. It says device group there because it says device group here. Service.deviceGroup means for in my service instance .deviceGroup gives you this leaf ref, which is a name of a device group. And then we have this NCS built-in model which keeps track of devices device and devices device group and all of those things. I'll show you. So here, device group is, I'll show you that Yang model. Here's one of the built-in Yang files for tailf NCS devices. Here. So in the built-in Yang that controls how devices, device, blah, blah, config, and devices, device group, or device templates, and so on. This Yang file is a built-in Yang file, but even these basic structures in NSO are controlled by Yang files. Everything is Yang, right? So there's a Yang file that corresponds to even those basic things built into NSO. And here it is. And in there, device group was spelled with a dash. So if I want to navigate that Yang model, it would be from the root, devices dot device underscore group, and then this one is keyed off by a name. So if I want to navigate into a specific device group, I have to use this Python subscript thing with brackets. Okay, which one then? And then I need to have a string of the device group. And the name of that one is what I take from the service instance, service.devicegroup in my service instance. That make sense? Not completely, or? All right, but that's just this magic mapping is doing that. It understands that minus is no good here, so I'll translate this character, which cannot be a good Python symbol, into an underscore. Yes, all special characters that are not good in a Python symbol turn into an underscore. We can take a look. It was actually dashed there too. Yes, this is inside list device group, and then they have this device name, which is a leaf list with a dash in. I mean, ITF recommends that you use dash when you are modeling in Yang, rather than underscore. Operators out there in the world, they are used to having dash in whatever commands and names they type. That's okay. But when we are programming, of course, we cannot use minus just like that. It wouldn't work. So then there needs to be some sort of translation there. And magic is doing that for us. Every strange character turns into an underscore. Make sense? So let's take this one line one at a time. Okay, so I have the root object that goes to the root of the Yang model. I navigate into the built-in Yang model for devices. I go there into the device group, which happens to be with the dash, but is translated to underscore here in Python. I want to find out the contents of a specific group, so I have to use this brackets to find out, okay, which one are we talking about, and fill in the name of that group. And the name of that group is something I take from the service model for this service instance. So service.devicegroup will be that name. So now it's pointing me to a particular device group. And now I want to find the list of devices that are part of that device group. So I go .device name, which happens to be a leaf list of all the devices that are in the group. So I get a list object here. So that's why the comment says Yang list. This is a list. And then I just use this list in a for loop. For dev in blah blah means for loop over that set of device names. Kind of nice, right? This is what if I dreamed how this Python interface should look like, this is what it should be. So I'm just so happy that they managed to get there. In Java, the same thing would be, well, at least 3 times longer. But you can do the same thing there, obviously. Okay, next thing I want to do, for each of these devices, I want to loop over all these applications that we want to identify with match flows. So then I have another loop saying, okay, for app in service.app, if you go back to the Yang here, you can see that this is the list I'm talking about. I'm inside the service. Here's the service point. And I'm inside the service, and I have a list of apps. So I want to loop over all of those apps. And what I do then, if I'm on the debug level, is deep enough, I just print, okay, I'm talking about app.name right now, okay? Since app is pointing to one of these instances in the Yang tree, app.name goes to the name column of that here, the leaf name. Say again? Yes, using magic if you are using this setup that I'm showing you.
Yeah, but what if I have multiple variables with same name in Yang?
That is perfectly all right, as long as they are not on the same level, and you cannot have same name object on the same level in Yang. But you can have, like name, as you saw already, you have name on the app, and you have name on the service. That is all right, because they are not on the same level. That just works. And dev was the name of the device, as you remember from up here, right? And then for each application, there's possibly multiple flows. For example, let's say something like Skype. It's using probably at least 20 different ports. It's like a train, four-wheel drive kind of vehicle taking you anywhere. As long as there's a connection to the outside world, Skype's going to find it and take you to the Skype servers. So there's lots and lots of different flows that Skype might use. So if you want to block Skype or give Skype a low priority or maybe high priority or something like that, you will have a long list of flows that you need to match, because all of these things are Skype talking. So then we want to loop over all the flows. If you go back to the Yang here, you can see that for each application, there's a list of flows with protocol, source port, destination port, or port range that we need to match, and possibly a DHCP as well. So for each of these flows, what do we want to do? Okay. I create a bag of variables. That's basically key value bindings. And into that bag, I'll throw the value of $device to bind that to the value dev, which is the string representation of that device name. Protocol will be, I'll just pick it up from the Yang. Flow.protocol. Flow was this thing that I was looping over here, right? Flow.protocol. Description will be, again, from the Yang model, flow.description. Actually, these simple things that I'm just copying like this, I don't even need to have them in the Yang model, in the Python code like this if I wanted to. I could have gone directly to the template and said, pick it up from the Yang directly. Sometimes that's a good idea, sometimes it's not so good, because now at least I have one place where I see all the values, and if I want to change the behavior somehow, I have it one place to go to. So it could make sense to do simple copying things like this here too. But let me open that. Actually, let's wait a second. I'll open those templates and show you what they look like. Okay, anyway, this is just binding values to these variables. So whenever in the templates I use $device or $protocol or $q or the description, it will just mean these values here. And then for DHCP, again, it's just picking up flow.DHCP. But the thing here is that DHCP is optional. It might not be there. In that case, it would have the Python value none. But none is not a good value to push into the template, because it will match the word N-O-N-E or something like that. So I only do this vars add thing if flows DHCP, meaning it is not none or blank or 0. Or otherwise, I'll shoot in a space there instead. This whole DHCP will just translate into an empty space. Just plain Python syntax. If it is none, then do this space, and if it is something else, then say DHCP, and then that number, 17 or whatever it is, something between 0 and 63. Make sense? Come on. Yes. Yeah, good. Then we have source port expression, which is any. This is corresponding to the IP address. I mean, in the iOS, this is only working for iOS now. This whole service is only geared for iOS devices. And the actual rules in iOS devices, the first word on these lines is matching the IP address. And we don't want to, this service is not concerned with IP addresses at all. It doesn't care. So it will always just hard code any for the IP. So it says source port expression starts with any. And then if we want to select on the port, then we will add some more stuff to it, like here. Check the flow source port to see if it is not any. Then check if there's a range, if the high port is set. Look how easy this becomes. Just say that, oh, source port not equals any, and flow source high port without a value, meaning that it has a non-zero value or exists. It is an optional thing again, but if it's not set, it will have the value none, so this will not apply. If it is set, then add to the source port expression the word range, low port, high port. Or if it's only if source port was set but not high port, then add to the source port expression equals and the source port. And the same thing for the destination. If it's not any, then look if it's range or if it's a single port and add that to this. Otherwise, it will be just any, or it will be any range from this to that and destination port any or something like that. So then push those things into that bag of variables, source port expr, dest port expr. And then we have this final thing to look at is the description. Remember, it is mandatory, but somehow people have the habit of apparently typing in the word exit as description, and that should mean don't put the description in there. So if you put description exit, don't actually push it. This is a real world example, so don't ask me why this is, but this is apparently how people want it. And if it's not exit, then actually it's putting a whole template for just that description field. This template will not be pushed if we don't have a description. So we have one template that's only dealing with the description, and we have another template here which is dealing with all the rest of the rules. I'll show you those. And then finally, before we close this thing, for every device, we have a piece of boilerplate template stuff we want to have push out. We want to push out a certain hard-coded policy map to each device and a certain class map to each device. They're not changing, so there are no variables in there. They just need to be pushed out to make sure that every device has these rules on there. So let's take a look at those templates. Any comments or questions before we jump into the templates?
So, Jan,
Yes.
between lines 38, 39, and 57, that's pretty much iOS specific, right?
Yes, it is.
So, what I'm thinking about is, if you want to make this multi-vendor and you don't want to go back to the Python code the whole time, every time you introduce a new vendor in your network,
Yes.
how would you solve that? Would you make some external code and external method or something like that that was the vendor-specific part?
Yes. I think the good solution to that is to make sure that you have this cross-classification package for iOS as one, then you make other packages for other device types, like Junos or whatever it is. So you have one per device type. And then you have a top-level package which is agnostic. It doesn't really know or care. And then it just applies this. Then you can make it easy to factor this out. Because, I mean, you could in the template sort of program with XPath expressions this sort of logic. At this level, I think that will be possible. But you will certainly hit the limits with XPath logic for how much complicated things you can do. And not everybody loves XPath, I know that.
It's a difficult trade-off, of course, because, I mean, an ACL is pretty standard, but if it's less standard, configure to try to push, and you have different packages for different vendors, and you need to keep capabilities in sync, then
Yes. So as long as we have this stupid CLI way of doing ACLs, I mean, ACLs, I'm really a software guy, and the way that ACLs as an API, looking at it as an API, has developed over the last 30 years, it's really evil. If I don't know who actually came up with that idea, but he might have come up with something that was very useful for humans, but looked upon as an API, it is terribly badly designed. So it is violating rule after rule for how you design nice interfaces for programming. I mean, he wasn't the guy that was doing this the first time around, and the under 100 that copied him, they weren't really designing an API, they were designing a command line interface, and for that, maybe it works. But looked upon as an API, it's really horrible. So that's why we have to suffer today with rules that have to be constructed with plus equals and whatever. And they are not transportable between different vendors and stuff like that in general. Even within iOS, you have to be careful about versions and stuff like that. You could, of course, you could certainly make a NED model that deviates from the tradition when it comes to ACL management. There are good ACL models. Even ITF have ACL models that are nice and clean, and if you use those, then this whole thing disappears. This whole problem goes away. Things become simple and smooth, just as you imagine they should be. But devices out there, I mean, they don't implement it. We could implement that ACL model on top of our NED, but a lot of people would be kind of surprised to see that it deviates quite a lot from the device. So that's why we have chosen to keep things very similar to the device. But that has a cost right here. But it's a good point. Excellent. Any other comments? I'll open up that template. Let's see here, packages. We can start up with this classifier rule, which is the main one. So this is what the template looks like. This one is applied on each device once for every rule. So if you have 100 devices with 100 rules, this is applied 10,000 times, right? So this navigates into the NSO device tree with devices, device, name, and here comes the $device that we bound in that bag of variables and that we supplied when we say template, run this template please with this bag of variables. So this will be that device. See how we have the tags no create here, meaning that whatever is within this tag and the devices should never be created, meaning the template is not allowed to create a new device. If you for somehow manage to get a device name into the device group that doesn't exist in your device list, actually that shouldn't be possible. But anyway, we say that this template specifically should not be creating new devices. If it is trying to do that, something is terribly wrong. We don't want that. And then we have, for the content, however, inside IP, we do want to create new content. So that's where we say tags merge. If you forget this tags merge, it wouldn't ever add any of this because it said, no, I'm not supposed to add this. I'm only supposed to modify the rule if I find it or something like that. But we want to merge here. So then we go to the config IP, and notice how this is, again, under URN iOS, so this is specific to an iOS device. In principle, we could have another section down here for other devices like Junos or iOS XR or whatever else. That would work just fine. The template applier will find the section that applies to this particular device on its own. Just stack on all the device mappings you have. But unfortunately, because the way ACL rules work, this sort of line with permit UDP or TCP and IP addresses and ranges and whatever is not universally applicable to other brands anyway. So that package won't work. Yes?
But you can add other variables which cover the universe.
You can try to make a service that is creating all sorts of possible variables and then make templates that are using them in a useful way. Yes, you can do that. So here you see those, the protocol, which is TCP or UDP, the source port expression that we just added together by any, followed by range and low port and high port and so on. And possibly this DHCP expression, which might be just a space, or it may be the value 17 or something like that, which is the DHCP match value. So this is the simple template that is being applied. We can open up the remark template. So if there was a description other than exit, it will also apply, this one, which is looking much the same, but it's only adding a rule called remark and that description line. It is applied before the other line, so it will go, the remark will be above the actual rule below every time on all devices. Say again? Yes. Because the templates that you have seen, which has a tag up here, which is service point, they are for the template only services. If you're making a service with a Yang model and a template and no code at all, NSO needs to know, okay, when should I apply this template? This template belongs to which service? So then you have to have this service point mapping in the template itself. But if, in this case, the Python code is explicitly calling out and saying, I want to apply this template by saying here, the name of the template, CrossClassifier remark, then you should not have a service point definition in there, because you have already registered here. This Python code says, I am responsible for this, so you will be called by the Python code. If you have this service point in the template, and so we go to the template directly and not go to your Python code. So don't have that in there. Yes?
On the template, on the line 6 you put tag match.
Yes?
Also on the line 11, why on the line 11? Yes, here it's okay, but on the 11 you need to...
All right, okay. No, this is not necessary. It's just, there's no reason why to have tags merge one more time here. I would say it's probably a copy and paste thing. Somebody copied this from some other place where it made sense. It doesn't hurt here, so it stayed. But a good question. Anything else? For completeness, I can just open up those two last, policy map and class maps. So this is the sort of boilerplate thing. This is hard-coded values that should also always be on every device. So the only variable in here is the name of the device that you should apply this to, and then just classify 0, medium priority 16, scavenger 8, blah, 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 blah. Okay, we want all devices to have this in there, because otherwise those rules won't work. And we have one more similar just to have the last one in there too. Which is similar, right? Go into the create a scavenger queue on the device, say match any, blah, blah, okay.
In those cases, would you prefer to use the replace tag instead of merge?
Yeah, definitely a valid point. I mean, if this is the final and complete list of everything that should be there, then definitely tags replace instead of merge would make sense. But it's also, if people go in and do manual additions to this, they would be wiped out if we have replaced there. But maybe that's a good thing. I'm not sure. You can choose. Okay, good. That was everything that I wanted to show you. So if you want to ask some questions or discuss something in what you've seen or what you haven't seen yet, then now is the time. Otherwise, you'll have a long coffee break. Yes?
Well, maybe my wrong understanding, but we are generating iOS code now. And what happens if we change the classification rules?
On the device?
No, on the orchestrator. We say, well, we need new classification rules for these bunch of devices.
Right.
They're already in.
Mm-hmm.
What happens underneath? Are those changed, or is also to remove the ACL from the box and regenerate because we don't have real Yang model talking to the iOS box?
That's actually a good question. It's not so much about service modeling, it's more about NEDs, actually, this topic. But yeah, so if we make a set of rules that we push out to the 100 devices in the network, and then we're adding one more rule, and now we want to update this network with this thing, what happens then? What you have to do in NSO, you just say, add this config line here, and say commit. That will push this updated config to all the 100 devices. Exactly how that happens, that depends on the NED. If the NED is capable of just pushing this one-line diff, it will do that. And if the devices are netconf devices, it will. It will push that one little additional line. With iOS specifically, I know that the implementation for ACL rules, again, coming back to this is evil on the device side, the NEDs, in order to handle this, they will have to remove the entire ACL config and push it there again. Because there's no, or not the entire always, but always, you have to remove all the rules until the first line of change and then push back. Because there's no way to reliably, and in all cases, get it right to insert a rule at a particular location within the rule set. Just because things are evil. But with a better interface, this works nicely. So it's just the CLI parser inside the routers that is not up to spec here. And the NEDs are doing the best they can to get their idea into the device as efficiently as possible. If that is not as efficient as you like it, I'm one more.
That's more the ACLs are ordered in iOS and
Yes, I get so sad when I talk about ACLs on iOS. So let's leave that for now. It's a NED issue. I mean, from an NSO perspective, NSO knows exactly what needs to go there. It has a NED to communicate this. If the NED is good, it will just communicate that diff. If the NED is not so good, I mean, if the device is behaving in a particular strange way, then maybe the device NED will have to compensate for that in ways that we don't like. But
let's assume we live in a perfect world where everything is talking netconf Yang.
yes.
What of all the stuff that you just told is still relevant?
The service stuff is all the same, right?
Yeah, the service it is, but the Python code, you don't need to build the whole.
No. I mean, it depends on the model. If the model stays exactly the same with one-liner like this, even in netconf Yang, you would still have to build it the same way. But if you use a better model, which has a way of inserting things in the right order and stuff like that, then you would.
Yeah, okay.
Mm.
So the model of the device should be better.
Yes.
To get rid of the issues that you see right
Both the parsing in the CLI and the model of the device should be better, yes.
If we have a system with a sysdb and we want to merge the Yang directly into sysdb,
Yes,
somewhere down the line, then this would all not be necessary anymore.
that's right. I don't know exactly what sysdb does for ACL rules, I don't remember, but there's a good potential that it's much more efficient there, yes. Anything else? Other comments?
At the beginning, you talked about IPython to navigate through the database, the magic database. Could you make some demonstration of this quickly, or we can navigate through the database with IPython?
Oh, IPython, yeah, sure. Okay, I can just quickly show you that I have the system that we just saw now up and running. So if I do a show full or show running CrossClassifier, I have enterprise network policy for the campus. I have a few queues, default scavenger signaling and video, and I've defined a device group called West with a couple of devices, and 3 applications. I have Avmar, rsync, and SnapMirror backup with a certain Avmar is running on TCP 27000, rsync on TCP 873, and SnapMirror backup on TCP 10565 as the source then, or until 10569, and always marked with DHCP 17. And if such traffic is found, it goes to the scavenger queue. If I go to configuration mode, I can go here and say devices, CrossClassifier, enterprise policy, campus, app, Skype, filter flow, TCP. I have no idea what Skype is running on for ports. It's a lot of them. Maybe 77. Any for the destination port. And let's put that on to default. This is what it'll push out to devices. iOS 0 is one of the members of DeviceGroup West. So this is what it will be adding here. Commit. Now it's going out. Oh, okay, maybe I forgot to start those simulated devices. Anyway. IPython, sure, I can show that. So if I do, for example, as you say here, for dev in root, and hit dot, hit tab, I get a lot of different completions here. Devices, okay, dot, again. Device. Print dev dot name. Then you see I have 3 devices on my system right now, iOS 0, 1, and 2. Yes?
I see you're using Python 2.7. Does it matter whether 2.7 or 3.5 or?
NSO supports both Python 2. At least 7, but maybe 6 or something like that also, and also 3.3 and above or something like that.
Can I query the variable from external database and return to DeviceGroup?
Say again, if I can.
Can I query the variable and the value from external database and return it to the DeviceGroup?
Yeah, I mean, in NSO, generally, you can integrate external databases to NSO if you want. And then you need to have a YANG model that represents that external data, and some code in there that can act as a data provider to respond to queries, what are the values for this and that. So that's definitely possible.
Could you run the IPython from when you do the commit to enter the interactive Python REPL from your service code?
So that you're single stepping and stuff like that.
Yeah, you're running your cp create and somewhere in the code you want to debug. Could you enter?
I have heard of people doing things like that. I don't know exactly how they do that, but I'm sure it's possible. I mean, it's Python after all, right? You can do whatever you want, and things are very interactive. I don't do this sort of thing. I always do the sort of log debugging that everybody else, most people are doing. But you can do that, yes.